Hello everyone and welcome back to another video on my YouTube channel. Today I'm gonna teach you how you control a specific block on your craft. Or maybe a specific group of blocks on your craft. So, right here we have 3 spinners, but we only want to control this one over here. How do we do that? First of all, we have to make this spinner distinguishable. And we do so by pressing Shift N on it and giving it a custom name. In this case I named it 9. Now I'm going to show you the code and how we control the spinner, which is named 9. So right here, this section down here, is what does the magic. First of all, we have here a for loop. And this for loop runs through all subconstructs, which include spinners. Spinners are subconstructs on our craft. And it compares the name of the spinner or the subconstruct it's currently looking at with code name. Code name is 9. So the exact same name as we named our spinner. If it's a match and the name of the spinner we're looking at actually matches the code name, then we insert the subconstruct identifier, so the ID of the spinner, into a table, into a list, and this list is named just a list. At the beginning it's just empty. Then we run through this for loop and we add all the subconstruct identifiers of all the spinners with the matching name. This is the idea. Let me explain more in detail what happens. First of all, we define codename. Yeah? That's just what we're looking for. Function update is called every game tick. Yeah, you should maybe already know that. Then we create an empty list, just a list. Yeah, it's empty. And then we are checking for the total amount of subconstructs on our craft. And yeah, we are just using a for loop, so it goes 0, 1, 2, 3 in our scenario, or just 0, 1, 2, because here's the -1, and we have 3 spinners on our craft. And for each index, for each iteration, it gets the ID of this spinner. This is just something you have to do because, as you will see later, the spinner we're actually looking at has the ID 25. So it has nothing to do with the index. You can find this function, of course, in the help section. And it's right here, get subconstruct identifier. This goes for all the functions I'm using, of course. Yeah. You can always find them in the help section. Okay. And yeah, for each subconstruct identifier, we are gonna get the subconstruct info, which is a block info object. Let me show you that as well. Down here it says get subconstruct info, which is what we're using. Yeah. Get subconstruct info. And we are and it returns a block info object. And a block info object is exactly this list, containing a bunch of different informations, but we're only interested in the custom name right now. This is why I used dot custom name, which gives me the custom name of the subconstruct, and I compare it to the code name. And if it's a match, then I'm gonna use table.insert to insert a specific value into a specific list. And in this case, I inserted the subconstruct identifier, so the ID of the spinner, into the list. So I'll end up with a list containing all of the IDs I want to aim at. And down here, I'm using another for loop, and I'll just use that to iterate through the list. So this is what this does right here. This is a for loop, and it goes through each element in the list, the first element, the second element, the third element, and it gives me the key, which is just 1, 2, 3, it's the position in the list, and it gives me the value, which is what is stored at this position in the list. And yeah, we stored subconstruct identifiers. So just to keep in mind what value actually means. Value is the subconstruct identifier. And yeah, this is just another random variable, right? You could name this however you want. I could also name this just A. It's just how the syntax works. Let me show you how this works. So I'm just gonna paste the code. And here you can see at position 1 in the list, we have the value 25. So this is the subconstruct identifier we inserted in the list right here. And we are now printing it in this for loop which iterates through the list. Let me add a second spinner so you can actually see that the list can store multiple IDs. Let me give this the name 9, and now it appears in the list, and it has the ID 30. Yeah, let me give it a different name, and now it won't appear on the list anymore. This is how this works. And now let me show you how you actually put this to use. So I'm gonna name both of them 9, and now I'm gonna control them. For that I'm gonna use the setSpinBlock rotation angle function. And I'm just gonna put it here in this for loop where we're going through all the elements in the list. And for each subconstruct identifier I can now choose an angle. I'll just choose 45. And now you can see both rotated to 45 degrees. And this is how you control multiple components on your craft by using this list. And now there's actually one more very useful thing, because we only have to iterate through this list. We only have to create this list once, right? You basically scan for all the spinners on your craft, save them in a list, and then you don't have to scan for them ever again. You can always use that list you created because it contains the IDs of all the spinners. And I'm gonna add this to my code. So this section up here, I'll only need to run through once. And I'm gonna get rid of this in the update function because this is executed every game tick again and again. I'm gonna create a new function. I'm gonna call it init for initializing. And I'm gonna put my code in here. And it's gonna return the list. And now I'm gonna have to call that section, yeah, init. And I'm gonna have to get the list in here. So what this does right now, it's basically the same code as I had it previously. Nothing changed. Does the exact same thing. I just basically outsourced this entire section, and I only wrote one line. And yeah, return basically just makes it that you can do it like so. So init1 actually is a value because it returns something. Yeah, this right here equals the result of this operation up here. So what it returns, just a list. This is how the syntax works. And yeah, I'm only gonna execute this line once. So I do that by using something like that. Init done equals true. Okay. And this is a global variable. And I'm only gonna execute this if init done equals true, then else. For example, like so. So what this does, yeah, it if init done equals true, then it will not execute this line anymore. So we first have to run this function to make init equal true, init done equal true, and then we'll never do this again. So we just have this list stored here. Just one thing, I can't make this local because it's inside this this if function. This is a global variable, but it doesn't matter. You could fix that, but it's fine. So, and yeah, now we're gonna use this instead. And this is basically just a performance upgrade, I would call it. If I now change anything on my craft, this down here won't change anymore. So I just copied the code over, and down here you see the same result as previously. We have those two spinners. If I now rename one of them, come on, it doesn't disappear anymore because we are not updating the list anymore. Yeah, we're done with dealing with the list. So we're still controlling both of them. I could still aim them. Yeah, by adding this line. As you can see, both rotate. Yeah. Yeah, this is how this is done. And you can do this not only for spin blocks, you can do this for any components you can iterate through. So the idea is the same. For example, you could use shield projectors, because they are somewhere in here. Right there, shield projectors 10. You can get the component type for shield projectors by using a component getCountType. Shield projectors was 10, so 10, yeah, just as the type. Right here, that's the type of shield projectors. You can get the count, the total count, and you can iterate through all shield projectors on your craft and only control specific shield projectors by putting them into a list. For example, if you have clusters of shield that work together, for example, you have one big front shield made out of several shield projectors, you could name all of those shield projectors the same way. You could name them all front shield, for example. And then you could turn them on and off at the same time by putting all of them into a list. You name that list all of my front shield projectors. And you can always iterate through this list and turn all of them on and all of them off. This is how you do it. And I have one last example. Because for other components it can get a little bit tricky to do that. For example, if you want to use, if you want to control missile controllers. Yeah, I have 3 of them on my craft right here, 1, 2, and 3. If you want to control them, you have to add an extra step to your function. So let's get rid of what we did down here. Let's only have a look at this. I decided to go with code word equals 3 in this scenario. And in this case, my init function is called listing, because it doesn't really matter. So let's start where the game starts, with the update function. I clear the logs, that's fine, just to keep it a little bit more organized. And here we have the same thing as previously. I ask if listing is done, yeah, if that's true. That's what we did previously as well. We only go through this once, yeah. And if listing done equals true, we call it a day. And our list is just done. And then, yeah, if it's not true, yeah, if listing done is not true, then we're gonna run listing, and we're gonna save what it returns, stuff I want to address. Yeah. And now let's actually check what this function does. It creates the same list as previously. Now it's not called just a list. It's called stuff I want to address. And we have the same for loop as previously. We have an index. for all. No, it's actually the same. Yeah, let me explain. We have the same same function as previously. For and so on. It's the same line as up here. We're missing the -1 actually. But yeah, it's the very same, because up here we're also iterating through all sub-objects, because you can only check for missile controllers on a sub-object. You cannot check for all missile controllers on your craft. That's not possible. You could do that for shield projectors, yeah. Doesn't matter what they are placed on, but for weapon systems and a missile controller for sure as a weapon system, it does matter. So we have to check for each subconstruct. For each subconstruct, we have to check for the missile controllers placed on it. So this is why we're going through each subconstruct. We're getting the ID for each subconstruct, and then we're we're gonna run through each weapon placed on that subconstruct, what we're doing here. Here we're getting the total count of subconstruct in that craft. It's the same as previously, but now with weapon systems and not with subconstructs like up here. And we're getting a block info object for the weapon. For that we need the subconstruct identifier, so the subconstruct it's placed on, and we need a weapon index. And I'm gonna check. I'm checking if I'm getting valid results, but it doesn't matter as well. Yeah, and then I used another very handy function. I used string.find. Down here, I directly compared the both names, right? What my block is named and what it should be named in order to end up in the list. And here I didn't use this double equal. I used the find function right here. And this basically, it checks if code word is 3, appears anywhere in the name of the block. So any weapon on my craft which has 3, the code word in its name, ends up in my list. So 13 and 33 are both valid names because both contain at least 1 3. Okay. Then it's just the same. Then I insert the basically I insert the information on how to find that block later on. I inserted that in the list. In this case, I have to save the subconstruct identifier and weapon index, because this is what, for example, the block info function requires. It requires subconstruct identifier and weapon index. So you always need that in order to talk to that block. Yeah, that's what identifies it. And I saved those in a list. And right now, here I defined the key as well by using this right here. I could just write this, and now this would be stored at position 1 in the list. But I've chosen a specific key, and my key is named subconstruct identifier. And this is where I can later on use .subconstruct identifier in order to get this value out of the list. This is the same thing we did with custom name down here. If you remember the the block info list, it's also a list, has a lot of different entries, and one is custom name. Custom name is the key of the actually value of the custom name of the block inside that list. If I use .custom name, I get the value, which is the custom name. Yeah, I use that here as well. And then I have the same for loop within pairs in order to iterate through that list. I can show you how this works as well. So it's basically the same code as previously. with a bunch of fancy add-ons. And right here you can see two missile controllers on my craft, which contain a 3 in their name. This one and this one. First one is right here. Second one is placed onto a spinner right here. And yeah, I can change this name, of course, to anything containing a 3. And if I then update my code, you can see that, yeah, it's still the same spinner, but it's still the same missile controller. Yeah, just a different name. And of course, if I remove the 3 from any of those, it won't be listed anymore. Now we only have 1. And this should summon it all up. Should be it. If you have any questions, feel free to ask me in the comments, or even better, ask me on the From the Depths Discord server. I'm gonna link it in the under the video. I hope you learned something and this was helpful. I tried to organize my videos a little bit better. There will be 2 cuts in this video as well. So I'm improving my production standards because I'm not satisfied with them. Yeah, and thanks for watching till the end. And maybe see you in my next video. I have some upcoming projects. I hope so, at least. Bye.